Okay, so lesson 12-3, how to divide polynomials. Well, let's start with what's a rational function. Rational function, notice we have the words ratio, means, and we could write it as y equals, or even f of x equals, really means the same thing, 2x squared plus 2 over x minus 1, something like that. So you have a piece on the top, that's a function, piece on the bottom. They're both functions. It's a rational function. It's a ratio. In the previous lesson, it was y equals just 2 over x. Well, this is actually a rational function, and so is the bottom part. So technically it was the same thing. We're going to show you how to turn this into this. Another example would be x to the third plus 2x all over 4x. Anything like that. So that's a rational function. So what does this piece in the middle mean? It means divide. So how would we divide them if we wanted to? Well, that's actually a very challenging thing to do, but I'll make it as easy as I can. Something even Morgan could understand. So what we want to do is go back to 4th grade, and maybe we'll see Deirdre there. So just divide two things. What's 123 divided by 31? Well, if you recall, we'd put it into long division. We'd put the top in here, put the bottom here, and then we'd stop and say, okay, 31 goes in there. Maybe we pull out a calculator 4 times. Let's try it off on the side. 31 times 4, 4 times 324. Nope, didn't work, so we know it's going to be 3 times. We'd place it there because we're actually multiplying. Excuse me. We'd place it here because we're actually multiplying in the 1 column. So 3 times 31 is 93. Subtract, we get 0. Get 30, doesn't go in, so we'd say remainder 30. And if we wanted to rewrite this, we would say it's 3 with a remainder of 30 over 31. So that's how we do long division. All right, so just showed you how to do long division with numbers. Now we're going to do it with polynomials. Divide 4x to the third plus 8x squared plus 10x by 2x. Well, according to what we just did, we put 4x to the third plus 8x squared plus 10x inside, and 2x goes here. How do we fit 2x into 4x to the third? Well, what times 2 is 4? 2. What times x is x to the third? X squared. Let's check that out. 2x squared times 2x equals 4x to the third. Looks good to me. So multiply them together, and I always draw a little arrow here. We get 4x to the third. And something we don't realize, we actually always subtract that. So it would be like putting a little subtraction up there. We're left with 8x squared plus 10x. What goes in 8x squared? Well, it's positive 4. 4 times 2 being 8. And an x. 4x times 2x is 8x squared. Subtract that out. I'm left with 10x. How many times does 2x go into 10x? Well, that's 5 times. 5 times 2x is 10x. Nearly forgot to put my subtractions in there. And remainder equals 0. All this nonsense is kind of in the way. So this is equal to 2x squared plus 4x plus 5. When there's no remainder, looks real nice. Usually there's going to be a remainder. You knew it. You know things are never going to be easy in math class. So now something much trickier. X squared plus 2x minus 3 over x minus 1. What goes inside? Top piece. What goes on the bottom, or out front? X minus 1. Now the key here is, do not worry about the minus 1. You need to account for it, but don't stress about it. It'll just come along for the ride. What times x equals x squared. Well, x. So let me try it. And it goes here because it's got to have the same power. They're 1 over 1. And let me multiply it. X times x is x squared. Good. That's what I wanted. But I can't forget about the other piece. X times negative 1 is negative x. Now remember, we subtracted, so I have to subtract everything. So negative, positive. X squared minus x squared is gone. 2x plus x is 3x minus 3. I'm going to erase my little arrows. What times x is 3x? Plus 3. Multiply it just to see how I did. 3 times x is 3x. 3 times negative 1 is negative 3. I'm subtracting it, so negative, positive, remainder is 0, which we don't actually need to write. So when I divide these, I get x plus 3. That's complicated stuff, so it takes you a few times to understand that. Don't worry, that's all we're going to do is practice that. What we do on the other side of the note sheet is just talk about a couple things that pop up. For example, this one. What's wrong with the way this is written? And even a teacher as evil as I am would never do that. So rewrite them. Put them in the proper order. Y squared plus 5y plus 4 over y plus 2. I'm going to pick up the pace a little bit here. Y squared plus 5y plus 4. Y plus 2 out front. I know that y times y is y squared. Y times 2 is 2y. Don't forget we're subtracting everything. So we get 3y plus 4. Going to erase these. What times y is 3y? Well, that's 3. So I get 3y. 3 times 2 is 6. Don't forget we're subtracting. We actually have a remainder this time. Remainder equals negative 2. So when I divided those, I got y plus 3, and I got a remainder, plus negative 2 over y plus 2. Where'd the y plus 2 come from? Right there, or if you like, right there. So that's how we do the remainder. Whatever the remainder is, goes on top, and whatever the divisor was, goes on the bottom. So that's one trick. They just put it in the wrong order. Pretty easy to understand that one. This one's a little trickier. You got to watch out. Let's put it in the right order. 4m squared plus 13, that's that one, over 2m minus 1, that's that one. So put it inside, and here's the problem. We're missing the next variable. So there's no m. So you have to fill one in, otherwise you'll mess up when you're doing long division. If you were dividing by the number 401, you'd have the 0 there. In this case, it's missing, so we write 0m, just so we don't forget it. And then the plus 13. 2m minus 1 goes out front. What times 2 is 4? 2. What times m is m squared? M. Multiply it. 2m times 2m, 4m squared. 2m times negative 1, minus 2m. Subtract everything, negative, positive, we get 2m plus 13. What times 2m is 2m? 1. Multiply it to check. 1 times 2m is 2m. 1 times negative 1 is negative 1. Make everything negative, negative, positive. We get a remainder of 14. So we get 2m plus 1, that comes from right here, plus a remainder of 14 over the original divisor, 2m minus 1. Confusing? We'll do lots of examples. By the way, use this for more than just graphing. Use this heavily in Algebra 2 and Pre-Calculus. So, what's the point for us? Well, graph that, which is kind of tricky. It's doable, but you'd have to go and mess with it and do all sorts of things. But you could just say, well, the top is 2x minus 1. bottom is x minus 2. Put a 2 here. 2 times x is 2x. 2 times negative 2 is minus 4. Change all the signs, and I get positive 3, remainder of 3. So this is equal to 2 plus 3 over x minus 2. I'm going to rewrite it. 3 over x minus 2 plus 2. How do we graph that? Well, that's what we spent all previous class doing. Plus 2 moves it up 2. Minus 2, we think it should go left, but instead it goes right. This is the parent function right in here. And this is the actual function, because the 3 moves it further away from the origin. Confusing stuff. We'll spend a lot of time doing lots of examples. Good luck. See you soon.